And now, the almighty Fogler with elements of chemical reaction engineering. Let's check it out. Hey, what's up guys? Welcome once again to the channel. It's always great to have you back, and if you are new, don't forget to subscribe, because in this channel we talk about chemical engineering for both students and professionals that are looking forward for learning more on the industry, companies, technologies, and much more. So stay tuned. Now back to the topic, and I really wanted to share you this news, guys, is that I will be making much more book reviews from chemical engineering books. So all the books that I already checked out in my bachelor's or university, and of course books that I have checked out for my process engineering career, and of course all the books that I have been checking out afterwards. More importantly, which books I think are very worth it. Some of them may be good enough, some of them certain sections, others that are mind-blowing, that are career-changing, and of course those that are definitely not worth it to spend time checking them out and of course making the investment. And to be honest guys, I'm very thrilled because I want to make this with a different scope, or let's say different idea. If you checked out my very old video on the review of the mass balance book, you will see that I had no idea what I was doing back then. I really just had a quick look on the book and didn't actually wait or compare with other books. It's something I want to change in this video series. Some of the aspects I really want to consider are, of course, the content itself, but more importantly, not just checking out the content for the sake of checking it out, but also trying to put myself in the shoes of others. For instance, if you're a student, is it easy for a student to learn from this book? Is it going to work? Are the exercises easy to understand? The tables friendly, graphics and all that? And if you're maybe a recent graduate that maybe you had the opportunity to check this out, is it easy to go back and reread the book and understand it? And of course, if you're a researcher, is it still relevant? Is it applicable to the industry or to the lab only and all that? Another idea I had is also to include a score, a numerical value that lets you know whether or not is it convenient or not to get that book. And of course guys, if you think there's anything that can improve this review, I don't know, maybe checking out the content or maybe checking out this specific topic on the book or so, let me know, because I'm looking forward for you giving me some feedback and making awesome book reviews for chemical engineers. Now let's get back to the actual book. And probably you're wondering, why did I selected this book, this chemical reaction engineering book? And to be honest, I have a very personal relationship with this book. This book was, I think I took it in the third year, or maybe between second and third year. And I really loved it because it was actual chemical engineering, but not only just generic engineering. For me, pumping, heating was okay, but reactor engineering was way the next level, because you have to control temperature, which means heat transfer. You have to control pressures, which means also momentum transport. You need to move it, you need to agitate or mix it. And also you have diffusivity, diffusion, mixtures, mass transfer. So for me, it was the fundamental part. And also it has chemical reactions. So pretty crazy things happening on this unique unit operation. So that's why I really love this book. The only book that I remember that was pretty straightforward was the one on energy balance. I'm not quite sure, but it was on Himmelblau, and I really loved that because it was also another book that you can take, read, and enjoy as a chemical engineering student. I had the very sad news on knowing via LinkedIn that Dr. Scott Fogler had passed away, I think maybe 1 or 2 weeks ago, and I don't know, it felt kind of rare. I don't know how to explain it, but it's kind of funny to know that there's this person that helped you understand a lot and learn a lot. So even though I didn't know him personally, I think there's this shared connection, the mentor and the mentoree. I don't know, but this is why I am selecting this as my very first book to start making reviews on this chemical engineering book series. And of course I will be checking out other chemical reactor engineering books, but to me this is like pure gold. Let's go to the actual topic, which is elements of chemical reaction engineering, which may or may not sound that straightforward. If you are a new student, maybe you think it's about chemical kinetics, chemical reactions, going to the lab or so. But if you're an engineer, you already know that this is most likely chemical reactions applied to the industry we want to make reactors. And I really think it's very on point. Every single chemical engineer should have this, for sure. There's no way on going around or just ignoring the subject, no. Chemical reaction engineering is something that must be taken seriously, especially if you're going to be a process engineer that will be working with actual chemical reactions. I know that there are a lot of chemical engineers that are not working directly in reactors, so maybe they're in pumping or compression, maybe they're mostly in mixing or in heat exchange, or maybe in separation processes that do not take any chemical reaction into consideration, and that's fine for you guys. But if you want to be called a chemical engineer, you have to know about chemical reactor engineering. One of the things that you need to consider for sure is the author. And not only that, is the author qualified or not to write on this subject? So let's give a very quick overview on Scott Fogler's biography. And I have it right here, Mr. Dr. Scott Fogler. And apparently he has been teaching on the University of Michigan. That was my knowledge. I think he has been there like for a long time. And okay, over the last 20 years, Professor Fogler has focused his research on problems in upstream research with a focus on asphalt thin and paraffin deposition. He has a graduated 45 PhD students, wow, that's actually awesome, and has over 240 research articles. So this is crazy. Not only a great professor, a great book author, but also a lot of articles which show how important he is in the field. Okay, so he received a Doctor Honoris Causa for his contribution to the field of chemical engineering through his teaching, textbooks, and research. So actually, that's a great way to get a Doctor Honoris Causa, actually making an impact to the chemical engineering community. And we can jump directly to the short biography. So this is also great. On the short biography, we can read that he was president of the American Institute of Chemical Engineers, which is also known as AICHE. Received a Bachelor of Science, or let's say a bachelor degree, from the University of Illinois, and his Master in Science and PhD from the University of Colorado, which you may already know, it's one of the best chemical engineering universities. So this is a very interesting thing. I didn't know that Scott Fogler had actually 12 books. I think I have only seen 3 or 4. So it will be great to check them out, including of course the one that we are reviewing right now, Elements of Chemical Reaction, 5th edition. I had the 4th edition. I don't know about you guys, maybe you're experienced one, you have the 3rd edition, or maybe older ones. We can be pretty sure that Dr. Fogler has a lot of expertise. So this is something that I really recommend, guys. Go and check out the author biography, try to get acquaintance, at least online, with them, and you will see that you may even resonate with them before the purchase. So when you make that purchase online, or maybe you go to your local library, you will enjoy it more because you already know the author, you know it's a great book, and you're going to be learning way much more. Now let's go and check out the content index, which is definitely something you need to do before any purchase. Actually, I always recommend you to check out the content index because that's like a laser view of all the things that you're going to read or study on that book. If you're interested in maybe batch reactor design and you go here and you don't find batch reactor design, well, you can just skip it. Or maybe if you are into biotechnology and you want to see how much biotechnology does this book has, you can do it. But if you buy this just because someone recommended it or because your teacher is telling you, you may end up with not the best reaction. Did you hear? Reaction. Now let's check out the content index. So I have here Slurry, which is a very serious company, has a lot of content. If you haven't checked it out, go and do it. There's a lot of content, especially for chemical engineers. You may find out even projects, homeworks, you may find out articles, a lot of relevant things. Okay, now this is the book. Unfortunately, this is the latest I could find, which is 3rd edition, but there's a 4th and currently a 5th edition. So if you want to check out those ones, let me increase the size of the window. And let's go quickly for the content index. Okay, so here it is. Let's talk about only the chapters: mole balances, conversion and reactor sizing, rate laws and stoichiometry, isothermal reactor design, collection and analysis of rate data, nomenclature, non-elementary reaction kinetics, steady state non-isothermal reactor design, unsteady state non-isothermal reactor design. And before you leave this video, guys, don't worry, we're going to explain a little bit on what are these topics. I know it may sound very complex. You're adding scientist term over scientist term and engineering term, a lot of terms which may not sound that logical right now, so stick to this video. Catalysis and catalytic reactors, external diffusion effects on heterogeneous reactions, diffusion and reaction in porous catalyst, models for non-ideal reactors, and the appendixes. Now let's go from the beginning. Now the very first thing you want to learn about chemical reaction engineering is that you need to learn about the chemical reactions, the chemical kinetics that are occurring, but more importantly, how these affect our reactor. So first things first, what you need to do is a mole balance. The mole balance is nothing more than the idea of this equation of moles go in, they may react or not, and they go out. Or they may not go in, they are formed and they go out. Or a mixture of these combinations, which you should already know from mass balance. So this is for me one of the most important parts on the book, because it is talking about the general equation which will allow you to understand other reactors, not only the ones that are proposed here, but other type of reactors. Of course, we are going to be checking out the most basic ones, which are, and please try to memorize these reactors: Batch Reactor, Continuous Stirred Tank Reactor, also known by the initials CSTR, the Tubular Reactor or Flow Reactor, those two types of names you will hear a lot, and the Packed Bed Reactor, which, as the name implies, they have a packed bed inside this reactor, which typically is for catalyst use. Okay, now once you get this, you are, I will say, 30% ready for chemical reactors. If you understand the core fundamental here, you're all set. Now, chapter number 2, conversion and reactor sizing, which is right here, is very important because, as you will see, especially in chemical engineering, sometimes you will simply see that your, let's say, reactants will react and form a little bit of your product, may not react at all, or may end up forming other type of materials or start an equilibrium. There's a lot of things that may happen on a chemical reactor. So this is the fundamentals on how much is our material converting into our desired product. Rate law and stoichiometry, this is very important. This is, to be honest, more about the chemical part. So if you're a good student in chemistry, you will have this as a piece of cake. What I really like about this part on the rate laws is that you have a review of all the important things that may be considered, and stoichiometry is one of the most important parts. You will see that it will help you a lot to have these tables, what goes in, what reacts, what forms, and what goes out. And now we go to the, I will say, the most important part as a actual designer or operator of chemical reactors, which is the isothermal reactor design. And I know it may sound kind of funky name, isothermal reactor design. Why do we need to be isothermal? You don't need to have it isothermal, but for sure, guys, if you're teaching something, the best way to simplify a reactor is by having a isothermal reactor. Why? Because you will see that temperature has a very interesting way to interact with all the chemical reactions. So for sure, you don't want that to be the case. And probably wondering how many chemical reactors are actually isothermal. And I will let you know that actually there's a lot of reactions that we keep at constant temperature. For instance, an engine should operate at constant temperature, meaning that you don't want the engine to heat up and you don't want the engine to be operated under very low temperatures. You want to have a very stable temperature. In this part you will see CSTR, tubular reactors, pressure drops, because of course when you have changes in mold you have pressure drops, and if you are not let's say playing with the temperatures, you may end up with other type of reactions. So by this part you are already a chemical reactor sensei. If you're in bachelor, if you have chapter 1, 2, 3 and 4 for sure, like very confident about it, you are all set. Not really, but this is like you're getting baby steps ahead. Now chapter number 5 is about collection and analysis of rate data, which is nothing more than trying to understand how chemical reactions work. How does it can benefit or not our reaction. In some cases you will see that chemical kinetics can either decrease or increase the size of a reactor, which of course implies more investment cost and of course more operating cost, because you need to clean or maintain larger vessels or so, which is of course expensive, human labor, more material to clean, more material to maintain, more material to automate, a lot of things that you already most likely know. Okay, now let's go to section number 6, which unfortunately here you cannot read, but it is about multiple chemical reactions. So far we checked out several chemical reactors and several chemical reactions that are taking place on first order at constant temperature, but the most obvious question will be what happens when we have or we want multiple reactions. And this chapter talks about it. And it's a very interesting way on how we can track individual reactions, let's say per se, simultaneously. Most likely you're going to be using computers or at least a spreadsheet such as Excel, but it's very important to know how to model it. Of course, you're gonna do the math, or maybe it's kind of tedious, but if you are able to model these via equations, you are all set. Chapter number 7 is not that common to encounter in bachelor, but I'm going to talk about it very quickly. Is non-elementary reaction kinetics, which means that what happens when you cannot assume that, for instance, if the reaction is A plus B equals C, typically you will assume that A is first order and B is first order. So that will be a secondary rate order. But what happens if it is not the case? Well, this is non-elementary, because you can assume that the first order goes like the first exponential and the first order of A and B are not compatible. So this means that you need to go and understand another way how to solve this problem. Okay, so far we have multiple reactions, we have a lot of reactors, and we have isothermal design. But what happens when temperature changes? Which is pretty common, guys, and it's also not only about being common, but many times you want to favor a change in temperature. Maybe it's going to be faster reaction, or maybe you want a slower reaction. Maybe you have high temperatures, you favor a a product to form. Maybe you have lower temperatures, you will favor, I don't know, that the reactant doesn't evaporate. There's a lot of ways in which you may want to play with temperature. And of course, you cannot say, I'm sorry guys, I just studied isothermal design, I will not put my hands on that. Of course not. And this chapter helps you with that. This is not so common to encounter in bachelor level, so don't worry for now. If you're into a master degree or maybe making a second course on reactor engineering, this is for sure relevant and going to be there. Okay, let's go for chapter number 9, unsteady state non-isothermal reactor design. Okay, so previous chapter was a steady state, all what you think is normal operation, but unfortunately there are cases in which you cannot just assume steady state. So this is when unsteady state design comes into action. To be honest guys, this is definitely not going to be on your bachelor level, so if you're just here for the university course, don't worry. But if you're in the master degree or so, this is one of the best parts in which you can use your equations, or let's say your differential equations, to start to get to know how systems interact between each other. For instance, here you will see a lot of batch reactors. What happens, because you already know that batch reactors may change in temperature, in mole, and in unsteady state. So this is way better form to model a batch reactor, rather than going to the simplest form of, okay, it's going to be a batch reactor which has single temperature, no changes at all. Chapter 10, catalysis and catalytic reactors, is also not so common to encounter in bachelor level, but if you have a little bit on that, it's most likely because you're going to understand catalysts, what are they, how do they work, and of course the steps in catalytic reaction. How you can, I don't know, try to understand the processes that are happening in these typically gas solid phases, but it's only for you to know. If you're into actual like master degree or going for further reaction engineering, this is one of the best parts, because currently catalysts are like getting much more importance, especially in oil and gas and pharma and in very specific or niche applications. So if you know about this, definitely you're all set. Chapter 11, external diffusion effects on heterogeneous reactions. So far we assume steady state, isothermal reactions, single reactions, very simplified. But what happens when you start adding materials? So once you're done in the reactor, you will see that there's an effect when there's diffusion between them. So this diffusion cannot simply be ignored. So there is a mass transfer process and a reaction process. So this is very interesting on how can we mediate both processes in a single unit operation. Chapter 12 is about diffusion also, but we're going to take it further. Now we're going to be talking about the actual interaction or the interaction of these materials in porous catalysts. So not only now accounting for diffusion in, let's say, liquid-liquid or liquid-vapor or vapor-vapor, but also in solids. And when we talk about solids, we typically are talking about catalysts. The most common type of reactors that you will encounter here are the Slurry Reactor and the Fluidized Bed Reactor. Chapter 13 is a very interesting topic. Actually can be a little bit boring, but once you know how to apply it, it's great. So it's about distributions of residence times. This is not only for reactors, but of course it makes a lot of sense for chemical reactors. So essentially what you do is first learn the residence time distribution function, and then you start understanding the pulse input, the step tracer experiment, which are very common to see. If you're going for a further course that is more advanced, you will see how the RTD can be applied to CSTRs and to laminar flow, to PFR, to all these reactors, and start getting a lot of interesting data that will help you to get further in your career. And finally guys, chapter 14, models for non-ideal reactors. So far we have assumed ideal behavior, and what do I mean with ideal is that the materials are mixed almost instantly, that the reactors are actually working as intended. So for instance, if you're in a CSTR, they are actually mixing completely. If you are in a plug flow reactor, there's full turbulent flow, that all this is like acting as we modulate, right? But in real life, you will see that there's these little details on the reactor, and many times these little details add up and end up not working ideal, or meaning that there's something else that is not helping our model work. And this is what the chapter is going to be talking about. So that was the content index I wanted to share with you guys. As you may have seen, is a lot of content, a very robust book, has a lot of concepts to be studied. But more importantly, what I like is that since chapter 1, 2, 3, and 4, you're getting deep into the actual design. Now let's talk about the formatting and all the extra little things that it is on the book. I think it's relevant to remark how the book is balanced. There's not much text, but there's not much images also. It's a great balance. I really think it's easy to read, easy to reference, because sometimes they will say you go to figure X9 and then you go and it's there. It's not like very difficult to find. That's great. There's also a lot of kinetic data. There's a lot of data itself that are presented in a very nice way. Also, all the equations are numbered one by one, so there's no missing steps. So whenever they reference another equation or mathematical step, you can go directly and find it there, which is, in my opinion, one of the best things that you will encounter in a book. You can also find sometimes a left-hand sidebar, which has a lot of like extra information, extra notes, random facts, or fun facts that help you to integrate more your knowledge. So this is also an extra on this type of books. Now let's talk about coherence, order, and chronology. For me, it's very important always to have a book that you can read from beginning to end without having to reference to the future or to the past, or I don't know, having chaotic things occurring in the book. So I really appreciate when an author starts with the very first things, then second, third, and final things. Unfortunately, I know that engineering itself is kind of hard to like go straight forward. Sometimes you need to go into the future and bring those concepts back and say, hold it for now, I will teach you later, but for now you need it to at least operate it mathematically, but then you will understand the concept. I know that. I know it cannot be always straightforward. So for this book, I will say that even though the book is not quite straightforward, I will say that you can go from chapter 1 to 6 without having to reference between each other or future chapters. So for that, especially because you're getting used to this topic, I will say this is also awesome. Okay, now let's talk about the problems and exercises, which I actually have here. To be honest, the problems that are solved are great. I think they are on the exact point in the sense that it's not that hard to get them and you can follow along. What I will say is that the problems may not be so, and this is very common in engineering books. So the presented problem is pretty straightforward, kind of easy to understand, and then the proposed problems are not that. So you will say we're talking about level 1 or 2, and then you go into the proposed problems to be solved by the student, that will be level 4 or 5, or sometimes maybe go back to 2. But overall, they are harder than the presented ones or solved ones. Now, value to money. Okay, I'm trying to balance how likely is someone to end up in chemical reaction engineering overall. So that will be a very low percentage. But I'm also trying to understand how important is this book for you to pass the course, which is very important. I will say it's not quite cheap. It's actually very expensive, but you can resell it. And it's going to be like very easy to sell, especially if you have some important notes. They can be sold with extra, I don't know, 20 bucks. It's a very nice book. If you can buy it and it doesn't bother that much into your financial status, will be great. If you can keep it, you don't need to resell it, will be great, because if you end up working as a process engineer in a reaction or reactor engineering part, it's definitely going to help you. But if you are not going to end up there, which is of course not likely, to be honest guys, there's not so many, in percentage, it's not likely that you are going to end up in reaction engineering or overall reactors. I will say then that's why I wouldn't recommend this book that much to be kept forever. So if you need to sell it for other books, go for it. So let's get a closure on this topic. This is overall a great book. If you can get it for free, or you can borrow it, or if you want to buy it, definitely worth it. You're going to enjoy it, you're going to learn a lot from it, and the topic is still relevant, it's still applicable to the industry. The book is well structured, friendly to read for almost all the public that are interested on those type of topics. Biotech, maybe chemical engineers, process engineers, mechanical engineers or so-ish. But it still has some little details, guys. So it's expensive, I know. It's not likely that you will end up using that book when you graduate, because to be honest, not so many people end up in reactor engineering itself. And of course, the people that actually end up there, they will have great value of it. And the people that actually end up working there will be a good stepping stone to learn about, but not sufficient to, I don't know, if you want to go into pharma, into polymers, into paintings, coatings, or into food industry, into biotech. It's kind of like a generic book, like a book for overall reactors, but it doesn't have that extra input, and it shouldn't have. So I'm being kind of harsh in that point, because this is a general reactor engineering book, not a reactor engineering book for all the applications of reactors. So yeah, I would say overall 8.5 or 9. Maybe because of the price, because it's, to be honest, it's very expensive for students. If you're graduates, it's still expensive, but definitely. Let's say 8.75. Yeah, 8.75 will be a fair book, because I'm trying to compare with not books on this topic, but overall chemical engineering books that are very cheap or very convenient, or you learned a lot. that your mind will be blown, that you will feel confident. So yeah, 8.75, that will be it. And guys, that was it. Thank you for joining me. This was the review for the almighty book of Elements of Chemical Engineering Reactions by Scott Fogler. If you have some things that you may want to share, please let us know in the comment section. If you have some recommendations of the book or some things that you want to share, what did you find interesting on the book? Maybe it's something that you didn't like or something that, I don't know, whatever you want to share on this book, more than welcome. And of course, guys, I'm looking forward for your recommendations on the next books that you may want to know or at least have a review. I'm thinking on making the one on unit operations next, but of course I'm open for what the audience wants. Okay guys, that will be it. I'll see you in the next video. Bye bye. So one thing that you may have marked is that we have the same colors. Yellow, blue, black. I don't know if this was unconscious or not, but kind of interesting.